What are ERC-20 tokens? When we come to this video, we will see in detail what are ERC-20 tokens. To understand this, we can start with the name ERC token. Okay, what are tokens means? In the context of blockchain-based application, tokens are like a cryptocurrency or coins that helps us to represent a digital asset. However, there is a difference between cryptocurrencies and tokens. The main difference is that if you wanted to create a cryptocurrency, you need to create your own independent blockchain. However, when we come to the tokens, you can create tokens on the other blockchain. So, tokens can be created and exist on the existing blockchain like Ethereum blockchain or Binance Smart Chain, and also you can use Solana blockchain. So, when we create a token, we can use another blockchain network. For this project, we use Ethereum blockchain network. So we will see in detail how to use the Ethereum blockchain network, and we will also talk more about ERC-20 token standards in the detailed way. What is ERC-20 token standard? As we said before, tokens are created and executed on the top of the existing blockchain. For this project, we use Ethereum blockchain to create tokens. Now let's start with what is ERC-20 tokens mean. When we start with the word ERC-20, ERC stands for Ethereum request for comment, and this 20 is standard number. So this ERC-20 is Ethereum request for comment with standard number 20. There are so many types of standards to create tokens like ERC-20, ERC-721, and so on. ERC-20, this is one of the standard on the Ethereum blockchain network which helps us create fungible or exchangeable tokens. The other token standard like ERC-721 is also the Ethereum token standard which helps to create tokens on the Ethereum blockchain network. However, those tokens are non-fungible and they are called commonly NFTs. So if you wanted to create NFTs or non-fungible tokens, you can use ERC-720 token standards. Also, there are other token standards we can use to create tokens on different blockchain networks. For now, that means for this video, we will use ERC-20 token standard to create tokens on the Ethereum blockchain network. So you need to understand this. ERC-20 tokens are one of the most common token standard to create a fungible token on the Ethereum blockchain network. Okay, now let's get started to create this project. This is a very simple ERC-20 token standard. We create a very simple token which is an ERC-20 token standard. So this is already a Hardhat folder. So I come to this contracts part and I will create a new file to create an ERC-20 token. So I come to this contract folder and I create which is fixed token. I wanted to create a fixed token. So I write fixed token dot sol. This sol is a Solidity extension, so I wanted to use the Solidity, so I created this fixed token dot sol file inside this contractors, and now I wanted to start writing a very simple code which is a Solidity code to create an ERC-20 token standard. So this is a very simple token which is no minting functionality and also no burning functionality. So very simple token which is a standard in ERC-20 token. That means Ethereum request for comment, and this is a 20 is a standard number. So we create this token, and this token don't have any functionality like minting and also burning. So what we will do first, I want to put this no minting, no minting functionality, also no, we don't have a functionality of burning, so no burning, no burning functionality, and also we mint the total supply when we deploy the smart contract. So this the total supply of this ERC-20 token is known, so the total supply is pre-mint. This is what we will implement this in this smart contract. So what we will do, we will implement ERC-20 token. That means the standard of this token is ERC-20 token. So standard is we will use this ERC-20 for the standard. So I come to this and implement all these four functionalities inside this smart contract to create very simple ERC-20 token. That means there is no minting and functionality, and the total supply is pre-mint. That means this token becomes a fixed token. So I give the name fixed token. So in Solidity programming language, first we need to write the compiler version of this smart contract. Compiling is important because we need to deploy this smart contract on the blockchain. So the blockchain not directly interacted with this smart contract. So this smart contract must be converted into a bytecode to interact with the blockchain. So compilation is important, and also to interact this smart contract with the front end like React or Next.js or Angular, we need to get another compile version of this smart contract, which is API application binary interface. For that, we need to compile the smart contract. For compilation, we need to first import the compilation version of this smart contract. For that, we write pragma, like this pragma Solidity, and we will put a compiler version. For this compiler version, I will put 0.8.10. This is a compiler version for this smart contract, and I also put here a caret sign. This caret sign implies that the compiler version, which is equal to and greater than with this 0.8.10 version and up to 0.9.0 version. Don't include that, but up to that. So this Solidity code is compiled with version this 0.8.10 and above until 0.9.0. And also when we write this, we also apply this or import this Solidity license identifier. So license identifier must be, for now I want to put this MIT. That means open source. So I will put these two things. Every Solidity code or smart contract needs these two things. The first one is the compiler version. So the compiler version you can put like this, pragma Solidity, and the compiler version of that smart contract, and this license identifier also important. So I want to put those two things like this. After that, I want to create a smart contract. So a contract inside this. So I write contract. It is very simple, like this contract, and I need a contract name. For this contract name, I want to put fixed token. You can give any contract name for this, and when we say this is a contract fixed token, and also this is a constructor function. Now it is empty. However, inside this smart contract, I want to create an ERC-20 token standard. So we need to implement this ERC token standard. For that, you need to import this ERC-20 token from the most popular library. For now, I want to use OpenZappling. So I implement this OpenZappling library. For that, what I will do is first you need to install it. So npm install at OpenZappling. Like by writing this, you can import it. npm install at OpenZappling, and you need to install those contracts from OpenZappling by writing like this inside this terminal, and you hit enter. It installs. I already installed this. So when we see this module, node module, there is here OpenZappling. I already installed it. So inside this OpenZappling, there are so many contracts like access, build, finance, governance, interfaces, proxy, token, utilities. So those are contracts inside of this OpenZappling library. So for now I want to use a token inside this, and when we come to this token, as you see, there is ERC-20, ERC-721, that means non-fungible tokens, and also this ERC-1155 token. So for now, I want to create this ERC-20 token. So I want to implement ERC-20 token standard. So I come to this ERC-20 token, and I want to import this standard ERC token. So what I will do, I come to this at the top part here, and I want to import this import, and from this I want to import this is first I want to write this open Zeppelin, then contractors, open Zeppelin contractors. After the contractors, there is here a token. So token. After we come to the token, I will come to this ERC-20, and inside this ERC-20, I want to implement this ERC-20.so. So automatically this code editor suggests me, so open Zeppelin contractors token ERC-20, so I import this like this. After I import this, I will also implement this or inheritance this fixed token with this ERC-20. For that, I come to this contract, and the contract name, this fixed token is, and also I will put this ERC-20 like this. So now this fixed token inherits this ERC-20 token standard. That means the functionalities, all the functionalities inside of this ERC-20 token standard are implemented inside this fixed token. After that, I come to this constructor function. This constructor function is the function, and it is called only once when we deploy this smart contract. So this constructor function needs, for now, I want to implement only some things, which is the name, symbol, and total supply of this contract. So I want to accept these three things inside this constructor function. The first one is name of the token. So I want to accept the name of the token, which is the token we create. So for that string, the name is already a string type, so string, and I want to put this name inside a memory, string, memory, and name, like this. The first one parameter is the name, second is the symbol of the token. We need to also the symbol, so the same symbol is also a string, memory, the storage, and the variable name is symbol. And also I want to accept the total supply of this token. So there is no minting, as we say before, there is no minting functionality. So we need to mint all the tokens, all total supplies when we deploy this smart contract. For that, we need also accept a total supply. So the total supply is a number, and I want to use this uint variable type uint256 total supply as a variable. I accept these parameters, these three parameters, name, symbol, and total supply inside this constructor function, and also I will put here payable, and inside this fixed token we implement this ERC-20 token standard. So before deploying this smart contract, this ERC-20 token standard needs two things, which is a name and symbol of the ERC-20 token. So ERC-20, this ERC-20 accepts two things. The first one is name. So the name becomes this name, and the symbol. Now we inherit this ERC-20 and pass the name we accepted from the constructor function and symbol from this symbol. And this constructor function, inside this constructor function, I also implement a minting functionality. That means we need to mint this total supply that is pre-minting. So we use a mint. This mint function is inherited from this ERC-20 token standard. So we write this mint function, and this mint function needs two things. The first one is the address, so the minting token which is sent to this address, and also how much tokens are minted. So for now we pass the address of the deployer of this smart contract. For that we write msg .sender. This msg .sender means the caller of this function. So this constructor function is called once, and it is called by a deployer of this smart contract. So when we deploy this smart contract, the total supply of these tokens are sent to this message sender, and this message sender becomes the owner of this smart contract. So the first parameter inside this mint function is this message sender, and the second parameter becomes total supply. That means the parameter we created here, the variable we created here inside the constructor function. So I will pass this total supply. By doing this, we can create a very simple fixed token. This is no minting functionality. All the total supply of this ERC-20 token is minted when this smart contract is deployed. There is also no burning functionality, and this is pre-mint total supply. As you see, the total supply of all the tokens are minted when this smart contract is deployed. That means when you want to create a token of 1 million total supply, you need to pass this 1 million as a total supply when we deploy the smart contract. And after that, we don't have a functionality of minting additional tokens. And also, we don't have a functionality to burn to decrease those total supplies. So it is a very simple smart contract which implements this standard ERC-20 token standard, and this is a fixed token. Total supply is known, no minting functionality, no burning functionality, and that symbol you need to pass to deploy the smart contract. You need to pass the name, symbol, and total supply, and you can create a very simple ERC-20 token standard like this. So this is the first project, which is the implementation of ERC-20 token standard with a fixed token. That means a fixed supply with no minting and no burning functionality, and all the total supplies are minted when we deploy this smart contract. Okay, now we move to create another token, which is the total supply is not known. That means not fixed. When we see this contract, this token is fixed token. That means we know the total supply, and there is no minting functionality in this Solidity code. That means we don't implement any minting functionality inside this token standard. However, now I want to create another token, which is ERC-20 token standard, and the total supply is not known. This is the next project. So I come to this contract part again, and I want to create another file, which is, I come to this and mintable token. I want to give this name. Mintable token dot sol, and now I want to create this ERC-20 token standard, which is the total supply is not known. That means when we need mint to a token, we need to mint. So total supply is not known. In this token, the total supply is not known. Another important is we implement a minting functionality. We implement this minting functionality, no burning functionality for now. no burning. And also when we create this smart contract and deploy, we need to mint some initial tokens. So minting we need to mint some initial tokens when we deploy this smart contract. Those are the main functionalities we will include here, and this also ERC-20 token standard. So now, like the previous one, I wanted to write a pragma version, that means a compiler version of this Solidity code. So I write pragma, like the previous one, pragma, and the version of this 0.8.10 and above, up to 0.9, and it don't include it. And this SPDX license identifier becomes MIT, open source. And now I want to create a contract. So I write contract, and I want to give a contract name. So the name of this is Mintable token. I give this name, and also I want to implement ERC-20 token standard. So is ERC-20, and I want to import this ERC-20 token standard from OpenZeppelin. So import at OpenZeppelin contractors token. Inside token, I want to use ERC-20, and inside this ERC-20, I also use is ERC-20.so, like the previous one. Here is I use this ERC-20 token. So I want to implement this functionality inside my token. So it needs name, symbol, total supply, and there is so many functions inside of this, like balance of to know the balance, transfer, allowance, approve, and I want to implement those all functions into my token, which is this mintable token. After that, I want to pass some parameters inside this constructor function. The first parameter I want to is the name of the token. So string, name is a string, so string memory, and I give name like this. And the second parameter I want to pass is a symbol, so string memory, this is storage, and the variable name symbol. And also I want to pass initial supply. As you see, we don't mint the total supply when we deploy the smart contract. What we need is we need to mint initial supply of the token, some tokens. After that, we also implement minting functionality inside of this ERC-20 token standard. So for now, I want to implement initial supply. For that, this initial supply is a number, and I want to use uint to 5 seconds and initial supply for the variable. After that, this token is payable, and ERC-20, I wanted to pass this ERC-20 standard. This ERC-20 needs two things. The first one is the name, and second is symbol to create this token. So I will pass name like this, name and symbol. And inside this constructor function is calls once when we deploy the smart contract, and we implement only mint some initial tokens when we deploy the smart contract. So I want to use this mint internal function of this ERC-20 token. You can come to this ERC-20 token from this OpenZapply library and you can check it. There is this mint function. So this mint function needs two things: the account and the value. That means the account is address when the minted tokens are sent to, and also how many tokens are minted and sent to that. So we implement this mint function. So I call this mint function this, and the address is message.sender. This message.sender is the caller of the smart contract or the deployer of the smart contract, and the amount is initial supply. I want to pass this initial supply. Initial supply. So by doing this, we create an ERC-20 token standard with mintable token, and now we also implement a minting function. So when we need to mint a new tokens, we need to call a function. So function, I want to write function, and the function name is mint. I give this mint function. This function is called only by the owner of the smart contract. For that, we need to, I want to change this we need to implement only owner functionality. So we also import access control. So import from this OpenZapply, import add OpenZapply contractors. Inside this contractors, we come to this access part, and inside this access we need to use this enable access enable this enable contract. So we need to import this enable.sol smart contract from this OpenZapply. When we come to this and see this function, there is a modifier which is only owner, because we need to implement this function to mint the tokens by only owner. So only the owner of this smart contract can mint this. So after we create this function mint, and we need to pass two things. The first one is the amount of the token we need to mint, and we need to pass the wallet address where the minted tokens are sent. So the first one is uint to 56, and I wanted to say amount, and the next is address, the variable type address, and the variable name too. That means to which address this amount of tokens are sent. So I will do this, and this smart contract is external, and I want to pass this only owner. I want to pass this only owner modifier. So I come to this and only owner, and inside this mint function, I want to call this internal mint function again, mint, and this mint function needs two things: the address and also this amount. So the first one is address, so amount I will pass 2, which is the address, and the amount of the token we need to mint. I want to pass these two variables like this. So this mint function is called by only owner. So this only owner is a modifier which we imported from this enable smart contract from the OpenZapply library, and this is only called by only owner or the deployer of this smart contract. And this mint function accepts two parameters: the amount and address to mint a new token. So the amount is the amount of token we need to mint, and also the address is where we send this amount of tokens to that wallet address. So this becomes 2 is the address, and the amount is this. Creating this function, mint function, we can also implement a minting functionality. So from this contract, this is a mintable token, which is not a fixed supply, which is a token, and the total supply is not known in here. And also we can mint tokens by calling this function, and only owner can do this. That means owner of this smart contract can mint tokens inside this smart contract, and when we deploy this smart contract, it accepts name, symbol, and initial supply. So this is a very simple mintable token which implements ERC-20 token standard, because we imported this ERC-20 token standard from the Open Zeppelin, and also we implement this ownable functionality. Only owner modifier, we use this only owner from this ownable smart contract, and we import this ownable functionality from Open Zeppelin library. We mint also implement a minting function inside of this contract, or this token is minted when we need to mint a new tokens. And when we deploy this smart contract, first we pass initial supply and some tokens are minted. After that, we need a new token. We can call this smart contract and mint new tokens. However, you need to remember this is only owner. That means this smart contract or those tokens are minted by only the owner of this smart contract. That is why we implement this only owner. So the total supply is not known. Yes, we don't know the total supply of this token, and we implement minting functionality here. We add this mint function, and also no burning functionality. For now, we don't have burning functionality. So in the next token creation, we need to also implement this burning functionality. For now, this is a very simple mintable token, which is an ERC-20 token standard. And when we deploy this smart contract, we need to only pass the initial supply of this token, and after that, where it is necessary to mint a new token, only the owner can call this function and mint a new tokens from this contract. So this is also a very simple contract. I think you understand the difference between the fixed token and also the mintable token. The main difference is this minting functionality. That means the total supply is not known in here, and when we see this fixed token, the total supply is known. So you can create two types of tokens by using this ERC-20 token standard. One is the total supply is known, and the another is the total supply is not known, and you can implement those functionalities. Okay, now we move to the next part of this project, which is creating an ERC-20 token standard and having a functionality of burnable. Previously, we created this mintable function. However, we don't implement function for burning those tokens. The main purpose of burning a token in this ERC-20 standard is decreasing the total supply. So we need to create a new function now, a new Solidity file, burnable token dot sol. I give this name, and what are the main function we will implement inside this ERC token contract. The first one is it is ERC-20 token. The next part is having a function of burnable. We need to burn tokens. That means we need to decrease the total supply of this ERC-20 token. And the next part is first we need to implement this burnable function in the fixed supply. So previously we see the fixed token. That means we need to fix when the total supply of this token when we deploy the smart contract. That means the total supply is known. For example, when we mint 1 million tokens, only 1 million tokens have. So we can also implement this burning function inside this fixed token, or also we can implement inside this mintable function. For now, we need to implement inside this mintable token. So we need to implement inside this mintable ERC-20 token, because we need to decrease the total supply. So the first one is we need to compiler version for this. So I write pragma like this, pragma solidity, and I want to put a compiler like the previous one, and license identifier MIT. This MIT is open source, so the compiler version of this becomes this version, sorry, 0.8, like this. And I want to create a contract. This contract definition, the contract name is Burnable token. I give this name, and I wanted to also implement this ERC-20. So is write this ERC-20 like this, because we need to create ERC-20 token standard, and we need to import this ERC-20 from OpenZapply. So import at OpenZapply contractors. Inside these contractors, we need to use token. Inside this token, we import this OpenZapply contractors, then token here. Inside token, we use ERC-20 and ERC-20.so. It is very simple like this. We import like this, and we need to pass some parameters for this constructor function, that is the symbol, name, and initial supply of the token. We also implement here a mintable token, and also minting token, and also burning token. So when we call a minting function, we need to mint a new tokens. When we call a burn function, we need to burn tokens. So what I will do, string memory name. The first thing is the name of the token. The next part is the symbol of the token. And we also pass the initial supply. Uint find seekers. We pass this initial supply, and payable ERC-20, and this ERC-20 needs two things. The first one is name and symbol, and inside this we implement mint. The address is msg.sender and initial supply. So this is a constructor function. We need to mint some initial tokens when we deploy the smart contract. We also accept the name, symbol, and initial supply of this token, and we will pass this name and symbol for ERC-20. This is the previous code we implement. Then we also have a function of minting. So function mint, and inside this mint function we need two things. The first one is the address where these minted tokens are sent, and also the next is amount. So address to the variable to, and amount like this. External, we need to external this function only owner, we pass here, and inside this minting we call minting function, internal function, and pass two things, this. So this is a minting function. I think it is clear. We will see in the previous this minting inside this mintable token. So now we will implement a new function which is a burnable. So we need to burn tokens from this total supply. For that, we create a new function, and I call this function burn. And this function needs two parameters. The first one is from which address those tokens are burned. When we see this, when we mint tokens, we need to mint some amount of token and send it to the address. So when we come to this burn, we need to burn those tokens from which address. We need to know that. So address, the first one is address from. This is a variable from which address we burn these tokens, and the next is amount. You into 5 seconds amount. How much amount of tokens are burned from that address? And I will also put this external, and I want to implement this burning function. This burn is internal function. You can check it when we come to this part, ERC-20 token standard. This is a minting function, and also this is a burning function inside this ERC-20. So for our token, that means for this burnable token, we inherit this ERC-20. So we can have access to these internal functions, the mint function and also burn function. So we need to call this burn function inside our burn function. This is internal function. This is a function we create now, and this burn function, when we see this burn function, needs two things. The first one is account. That means the tokens from which address these tokens are minted, burned, and this is how much. This is a value how much tokens are burned. So we come to this. We need to pass this. The first one is from. I pass this variable from, and the next is this amount. So by doing this, we can create a burnable tokens. This burnable token, the name is, it firstly accepts the name, symbol, and initial supply when we deploy the smart contract. After that, when the deployment is executed by this message.sender, the initial supply is sent to this address, the message.sender. That means the caller of this function. So this function, constructor function, is calls once, and this message.sender becomes the deployer of this smart contract. So this initial supply is sent to the deployer of this smart contract or the owner. After that, we also implement this mint function. This mint function is to mint a new tokens when we need to mint. So this increases the total supply. The total supply becomes this initial supply plus this minting amount. So when we need to mint a new tokens, only the owner can mint these tokens, and also we implement this burn function. That means whenever we need to decrease the total supply of this token, we need to call this function, and to call this function, we need two things. So first one is the address. That means from which address those tokens are burned, and the amount is another parameter, which is how much tokens are burned. And this burn function decreases the total supply by this amount. So by doing this, by implementing this burning function, we can decrease the total supply of this ERC-20 token. So in this project, we will see three things. The first one is a fixed token. We create a fixed token, no minting, no burning functionality. The next is this minting token. We need to mint new tokens. However, we don't implement a burning function to decrease. Inside this token, this is only increase the total supply. So to decrease the total supply, we also implement this burning function. So by doing this, we can create a burnable, mintable, and not fixed total supply of this token. So your ERC-20 token may be depending on your interest If you wanted to create a fixed supply, like 10 million total supply, you can use only these things like this. Only you mint the total supply where you call or deploy this smart contract. Another approach to create ERC-20 token is by implementing a minting functionality and also this burning functionality. So it is depending on your interest and your project. So you can implement those things by using these functions. By calling mint function and burn function, you can create ERC-20 token standard. That is, the usage is up to you. However, you can approach these ERC-20 token creations by seeing those opportunities.